Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. So this is Pelarasan for Zero2Hero program, Slot 3, that we run today, 24th of January. Okay, with mode online, or in other words, you can do anywhere you want together with your groups. Okay. Okay, so let's go through the Pelarasan. This is the question number 1. Consider the curve given by equation fx equals to 2 minus x squared given to you quadratic equation. And then part A, they want you to sketch the region bounded by the curve fx, gx, line x0, line x equals to 1. Hence, find the area of the region. Hence, find the area of the region. All right. So the first step is to sketch. So what we can do is graph of fx equals to 2 minus x squared is a set graph. Set graph, right? Because of negative x squared. And then we knew already that this quadratic is without b. Without bx, without b. Okay. So without b, so means that symmetrical about y-axis. So this is y-axis. So your graph will be something like this, x-axis. And then this part here will be 2. Okay, will be 2 because of 2. Your C is 2, right? Okay, in this case, coincidentally, it will be the maximum point. And then fx done already sketching fx. What about gx? Gx is x square only, so it will be a smile graph. And then the intersection will be at origin. So this is going to be your gx. Because gx is x square only, so your c is actually at 0 here, origin. And then without b, so symmetrical about y once again. And then this one just now, the function is 2 minus x squared. So done already with the first two. And then the lines x equals to 0, lines x equals to 0 is actually the y-axis. So done already, x equals to 0. And the last one is x equals to 1. So x equals to 1, so we need to calculate a little bit to determine this one first. Let's determine this point. So how do we get this one? This is the intersection point between function fx and function gx. So what we can do next is, this is function fx, and then equate it with function gx, x squared. So then we rearrange, therefore we obtain x squared, 2x squared, right? 2x squared minus 2. Okay, and then this one we can simplify, becomes x squared minus 1, therefore 0 is x minus 1, x plus 1. So means that x equals to minus 1, x equals to 1. So we got two intersections, just like the one that we obtained from our graph. So this one going to be minus 1, this one going to be 1. Okay. All right. So this is the line that we want. This is the line that we want, which is x equals to 1. Therefore, if let's find the area of the region bounded by these four things. Okay, bounded by fx, gx, x0, and x equals to 1. Okay, as you can see, this one going to be the region. Why? Because this one is bounded by x equals to 0, and then somewhere here is x equals to 1, and then this is the graph of fx, and then this is the graph of gx. Okay, so this is going to be our area. So to calculate the area, so this is our area. It is easily to do it towards x-axis as your base. Okay, so what does it mean? We will do integrating your functions with respect to x. So by looking this way, so we are dealing with dx. Okay, by looking this way, so means that this is your first function, this is your second function, right, before you reach your base. So the first function is going to be of x, fx. This is going to be the first function. The second function will be your gx. So minus gx. And then the limit of the graph, by looking at this way, so the limit will be 0 until 1 maximum. So 0 to 1. And then therefore simply substitute 0 to 1, and then fx, altogether your integrands must be in the form of x. So 2 minus x squared for fx just now, minus dx is x squared only. So now we obtain already the equation, the expressions of integration for finding the area. Therefore, before you proceed with integration, make sure you simplify your integrand first. So 2 minus 2x squared dx. And then simplify this one. Integrate 2x minus 2x cubed over 3, 0 to 1. And then proceed with substitution of the limit 2, 1 minus 2, 1 cubed over 3. Upper limit done. For lower limit 0 to 0 cubed over 3. And then we knew already that this one going to be 0. So calculate this one, 2 minus 2 over 3. Therefore, this part will be 4 over 3 unit square. That's it. So done already with the first part. Okay, so let's proceed with part B. Find the volume of solid generated when the region bounded by the curve fx. So in this case, we are focusing on fx, lines x equals to 1, line x equals to 2, and given to you already that rotate about x-axis. Therefore, once again, our case going to be dx. dx is going to be for dx. And then straightforward, in this case, no need to use the graph because straightforward given to you, bounded by the curve fx. So our function going to be fx. Okay, and then our limit going to be 1 to 2, 1 to 2. But be careful, for volume, we need to add on pi, and then our function need to be square. That's the difference between area and volume. So now we obtain already the expressions finding for volume. Therefore, we can proceed with our substitution of fx first. Fx just now is what? 2 minus x squared, right? Okay, fx is 2 minus x squared, altogether squared dx. Before you do your integration, once again, simplify your integrand first. So 4, expand this one. 4 minus 4x squared plus x power of 4, right? dx. So integrand done. Proceed with integration. 4x minus 4x cubed over 3 plus x power of 5 divided by 5. The 1, 2, 2. Okay. So pi remains outside of our... What happened? Okay. So pi remain outside. So what we can do is we do two similar size brackets separated by minus. Substitute the upper limit first. 4 times 2 minus 4 times 2 cubed over 3 plus 2 power of 5 divided by 5. And then lower limit for 1. 4 times 1 minus 4. 1 cubed over 3 plus 1 power of 5 divided by 5. And then let the calculator do the job. And then you will get 13 over 15 pi unit cube. Okay, so done already with part B. Move on to question number 2. So we actually move on to trapezoidal rule. 4 subintervals. So the keyword is 4 subintervals. This is the question. Build it with the limits and then correct to 4 decimal places. Okay, so 4 subintervals. So means that your n going to be 4. And then our A is 0, and then our B upper limit going to be 2. And then by using these 3 clues, we can get our H. Our H is B minus A divided by N. In this case, we get half, or actually, we can do 0.5, up to you, which one you prefer. All right, and then please be alert. They want you to answer in 4 dp. Therefore, calculation need to be 5. Okay, calculation need to be extra 1. Must extra 1. Extra 1 dp. Okay, so what do we do next? We do a table of trapezoidal rule. This one for x, then this one for y. If you're starting with x naught, so your n is 4, so you need 5 ordinates. So it will end up at x4, x sub 4. So 5 ordinates here. As you can see, 5 ordinates. It must be extra 1 than your n. You mesti n equals to 4. Ordinates will be plus 1. 5 ordinates. All right, and then somewhere here we will get y0 and then y4. And then we split into two parts because we want first and last, and then together with y remaining. All right. So please bear in mind that our y is the integrand, x square ex in this case. Therefore, let's start with our a. So this one going to be 0, and then we add on 0.5. 0.5, so 0.5, and then 1, 1.5, and then 2. And then guys, you need to be alert that this one must be your a, and then this one must be your b. Okay, if you can't get your b to be 2, so it means that something wrong with your calculation of h, or maybe something wrong with your add-on here. All right, so let's proceed with the corresponding value of y. So when x0, y, you substitute 0 square e powers of 0. In this case, you will get 0, right? You will get 0. Okay. And then calculate for y4, substitute. You will get 29.55622. As I told you just now, make it extra 1 than the one that they asked for. They asked for 4 decimal places for the final answer. So means that calculation need to be 5. Okay, and then keep it consistent. So for y1, calculate, and then we will get 0.4121, and then y2 2.71828, and then y3 will be 10.08380, consistently 5 decimal places. And then what happens next? What happens next is we total up this part, and then we get 29 in 0.55622. And then for this one, you will get 13.21426. All right. Okay, so done finding our x ordinates and y ordinates. Therefore, we can substitute into the formula. The formula will be, you need to rewrite back your question. Limit 0 to 2 for the integrand of x square ex dx equals to. So the formula will be h over 2 times, times y0 plus y last, y4 in this case, plus 2 times y1 plus y2 and plus y3. So this is the formula of trapezoidal rule. But we can easily from our calculation, we get 0.5 here. This is y1 plus y0 plus y last, y first plus y last, sorry. And then this is the y remaining. So easily we can substitute 0.5 divided by 2. So this part going to be 29.55622 plus 2 times plus 2 times 13.21426. Okay, so this one should be approximately equals to. Okay, and then you will get the final answer will be 13.9962, and then you need to understand that this one must be 4 decimal places. Finalized. So you get the answer already for question number 2. All right, so move on to question number 3. Give me a second. All right. Question number 3. Once again, using trapezoidal rule, and then in this case, given to you 3 subintervals, limit pi over 6 to pi over 3, and then 3 decimal places for your final answer. All right, so let's take out the clue. And they want 3. And then your lower limit is pi over 6. Your upper limit is 2 pi over 3. So this is your upper limit. And then from these 3 clues, you can get your H. Your H will be upper minus lower, and then divided by n. In this case is 3. By calculating this one, you will get pi over 4. So your H is pi over 4. And then once again, our calculation need to be final answer 3 dp. So calculation need to be 4 dp first. Okay. This is final answer. So calculation must be 4 dp first. 4 dp. Okay, so let's do the table. Once again, table for x, this one for y. So take a look at your n here. N is 3. So x, if you start with x naught, so end up with x3. So corresponding y last, split into 2 parts, y1 and y2. In this case, going to be y remaining. What happened? Y2. All right. So let's fill in the blank. Be careful. Your y function is 1 over sine x in this case. By looking at the value given to you, the value is in the form of radian. Radian. So be alert. Make sure calculator need to be mode radian, not degree. Okay. So in this case, your x naught pi over 6. We always start with our value here will be a. And then you add on. And then you need to add on pi over 4. You need to add on pi over 4. Therefore, this part will be pi over 3. Add on another, this one is plus, plus pi over 4. And then plus another pi over 4, you will get pi over 2 here. Okay. Okay, sama juga. And then add on this one. You will get, make sure you get similar as your B. If it is similar, so means that you are still in the right track. Okay, find the corresponding value of y naught. In this case, it's going to be 1 over sine pi over 6. This is the calculation. You will get, in this case, 2. And then for y last, you will get 1.1547. Be alert, we need to make it 4 decimal places in our calculation. Y1 as well, you get 1.1547. And this one, you get 1.1 actually. For decimal places is 1.0000. This one 2.0000. If you want to make it consistently for decimal places. And then don't forget to total up y first and y last, and then y remainings. So in this case, it's going to be 3.1547. For this one, it's going to be 2.1547. All right, so done already with the table. As I told you just now, if you want to start using the formula, make sure do the correct way. Write down your subject first, which is the question, pi over 6 to 2 pi over 3. Integrand is 1 over sine x dx. So approximately equals to, so we do the formula just now in the previous example. So let's straightforward. Substitute the corresponding value. So the corresponding value will be, this is your h, y first plus y last, and then y remaining, right? So the formula will be pi over 4 all together divided by 2, h over 2, y first plus y last, sorry. So this one, and then plus 2 times this one, 2.1547. And then let the calculator do the job. So we will get in this case 1.954 and then make it 3 decimal places. So this one going to be your final answer. All right, so done already with question number 3. Move on to the last one, question number 4. Okay, question number 4 is the most possible question that will come up in exam, because involving the definite integration together with the trapezoidal rule by using the similar integrand, and then in this case they want you to calculate percentage error. All right, so let's solve the first part. The first part is solving the definite integration. 0 to 1 to 1 plus x dx, and then you need already to integrate this one. What we can do is 2 ln 1 plus x, and then differentiate inside, bring downward over 1, so means nothing in this case. So all together inside the big bracket, limit 0 to 1, and then substitute the corresponding limit. Two similar size bracket separated by minus, so 2 ln the first bracket will be 2, right? And then the second bracket will be 2 ln 1. So ln 1 is 0, so the second bracket will be 0. So left us with the first bracket only. 2 ln 2 is actually ln 4. So done already solving by using the definite integration. So move on to the trapezoidal rule. Trapezoidal rule, in this case, they want you to make it n subintervals. So n equals to 4. And then we knew already that our limit starting from 0. And then our upper limit starting end up with 1. So by using these three clues, we can get our h, upper minus lower, divided by n. So in this case, we get 1/4, or give me a second. What happened? Stuck. Okay. So 0.25 if you want to make it in decimal points. All right, and then we can proceed with, be careful, 4 significant figures. So calculation need to be 5 significant figures. So this is our x, this is our y. Y, the formula will be 2 over 1 plus x, your integrand. So let's start with x naught. So we will end up with x 4, right? So means that we have 5 ordinates. So start with A is 0, and then add on 0.25, 0.25, and so on. So here you get 0.25, this one 0.5, this one 0.75, and then end up with 1. Make sure that this one is B. Yes, correct. B is 1. Okay, so y not, and then y last for the first column of y, and then followed by y remaining, y1, y2, and y3 in this case. All right, so y naught is 2 over 1 plus 0. In this case, we get 2. All right, so how about the y4? Y4, in this case, we get 1. Y1, the calculation is 1.6. So if you want to make it 4 significant figures, therefore 5 significant figures in calculation. So this is 5 significant figures, 1.3333 for y2, and then y3, the calculation will be 1.1429. Make sure the values returned is the one after round off correctly. Okay, so calculation of y first plus y last will be 3. And then for the y remaining will be 4.0762. And then easily we can substitute into the formula, but as I told you before, we write your subject clearly. Give me a second. Stuck. Okay. So approximately equals to h over 2, right? H is 0.25 over 2. times y first plus y last, which is 3, plus 2 times y remaining, 4.0762. And then calculate this one. What do we get? Calculate this one. We get 1.39. Start again. 1.394. Be alert. This one must be 4 significant figures. 1.394 only. And then we are not done yet. We still need to calculate the percentage error. The last part, calculate the percentage error. So to calculate the percentage error, percentage of error, the calculation need to be 1.394 minus ln 4. Okay, it's going to be approximation minus actual or actual minus approximation, up to you, as long as need to be inside a modulus, because we don't want error or percentage to be negative. And then divided by always divide by the actual value. You need to understand that this one is actual value, this one is only approximation. So percentage of error always divided by actual. And then don't forget to times 100 because we want percentage. And then calculate, you will get 0.56%. So that's it, guys. Done already with the Pelarasan schema for Zero2Hero slot 3. Okay. Thank you for your cooperation. Please help your friends. Okay. So then we will get the best result for our PSPM. Thank you very much for watching. Thank you.